I'm Ellen and I'd like to welcome you to Gardening and Changing Climate. It's a workshop developed by the Northwest chapter of the University of Vermont's Extension Master Gardener program. To give you just a little bit of background, the workshop probably began when my strawberries drowned a couple years ago. And unexpectedly, I'm not the best gardener in the world, but I was really puzzled because, I hadn't had problems before. My family, unfortunately, did not receive the, I usually can and freeze the strawberries for winter when it's dark and dank and mean, and the scent of the strawberry will just send you happily over the moon. I see everybody smiling, you know what I'm talking about. So we missed the strawberries that year. The following year, my lavender, which has been such a joy in my life, I had a whole beautiful bed of it. I live up on Mount Ellen, and we have a very big snow cover, as most of you know. That year we didn't get the snow cover, and I lost the entire lavender garden. And that was a tragedy, not just for me. I have to say it was one of the joys of my life to be working there alongside a couple of hundred bees who were so busy with the flowers, and the sun coming down on their little gossamer wings. It was like looking at a bed of jewels and gems. It was just an incredible experience, and one that I've always treasured. So I'm mourn the loss not only for the experience that I had, and the beauty that I had, but also because our bees are so endangered at this point in time. So my lavender croaked. Last spring, my spinach drowned in a well-composted, well-drained bed. With various things had been grown in for about 15 years. And last fall, which is really what got me thinking, was that my corn never matured. It didn't mature because I had to plant it a month later than usual because the soil was not warm enough for the seed to germinate. Now, at first I blamed myself, as all my friends can attest, I'm not the best gardener in the world, and certainly not in this room. But I began to realize that it might not be just me. It was also the fact that I was running into climate challenges that I just didn't expect. I was looking too much in the manuals and just, plant dates and hardiness zones, and something was out of alignment, I felt, but I didn't know what was going on. So I started asking myself, how do you garden in a changing climate? Whatever is causing it, how do you cope with it? So in talking with UVM scientists, and as those of us who are master gardeners know, one of the real benefits of being a master gardener is that you can grab one of the soil scientists every once in a while and shake them until they give information. But in talking with the scientists, I've come to suspect that the answer is that we need a new conceptual framework that will allow us to think about our gardens differently, and that's why we're here today. Most of us already have the training and the tools to meet the challenge. What we need is more information about how climate changes and which of the many tools we have in our garden sheds we should be yanking out in response. So here to give us that information is Dr. Leslie Ann Duquesne-Giraud, the Vermont State climatologist and associate professor at UVM and an advisor to the National Oceanic and Atmospheric Administration. Also here is UVM researcher Rachel Chapman, standing in the back of the room, a PhD candidate at UVM's Vermont's Agricultural Resilience in a Changing Climate Initiative. Now, I have to tell you, the title of that project, when Rachel told me, I shrieked at her on the phone. I said, but that's what the workshop's about. And she goes, yes! This is wonderful. There's a whole initiative around this that I'd never even heard of. I was very excited. And I'll be very excited to see what comes out of that initiative. But Rachel is also an certified organic farmer. If you purchased produce or vegetables up at the Burlington Farmers Market, chances are you may have had some of Rachel's products from her farm in Vermont, in Moncton. Now, with that, I think we're going to just get started, and I'll cede the floor to Leslie.
Well, thanks, Ellen, for that very gracious introduction. Sat there listening to you, and I thought there's nothing left for me to say. She sort of pretty much covered it all in terms of why we're here and some of the things that we're actually interested in. So I guess we should pretty much dive into things. And if it gets too dark in here at any point, please wave so that I'll know to kind of liven things up either verbally or try and liven them up here as well. Okay, So I thought one good place to start would be with this slide, which you can find on YouTube, which takes you through the entire year and shows you the green up in the spring and into the summer, as well as the senescence that occurs in the fall, and shows you both in the northern hemisphere, the polar regions, which are of course of concern to us as climate change continues to evolve, and the impacts that we see in the high latitudes, but it also shows us what's going on here at our latitudes. So what I thought I would do is to try and put together some of the things that you may be interested in learning about, that you may have had questions about, and put them in a context so that we can have a discussion at the end of all of this. Okay, so please either keep track of all of your questions as we step on through and look at our vegetation. So we're going to talk a little bit about how weather and climate affect our vegetation, be they agriculture, be they crops, be they forests, be they their gardens. We'll talk a little bit about some of the environmental factors that need to be kind of considered, because Vermont does not look like Kansas, which means we've got slight differences in how rainfall affects us here. And then we'll talk a little bit about climate change, which is, of course, the thrust of this workshop itself. So a couple of things I'm going to throw out right off the bat so that we're all on the same page with looking at this. We know topography makes a big difference. We know that if we're looking at the intervale here, that the conditions that we'll expect from a soil perspective, from a growing condition perspective, are going to be different than if we had an upland farm. Okay? So topography is one of those things that you cannot leave out of the picture when you talk about gardening and farming in Vermont. Another thing that we need to talk about is microclimate. And this we actually live on a day-to-day basis. So your microclimate means that the conditions that you are in a particular region are going to be driven by not just the topography, but where your winds are coming from, how much rain you get, and that's going to be different from your neighbor 2 miles down the road. Right? So that you might get your strawberries flooded, but some of your neighbors were just perfectly fine because their microclimate was really, really different. So knowing some of that's also important. You talked about plant hardiness, and I'll show the latest map, and if it works, does it not work, how do you use that? And then we'll talk a little bit about understanding seasons and factoring that into some of the stuff that we did. So what we're trying to see here is the influence of topography. So let's work with the upper slide. Can you see this up in here? Mm-hmm. Okay, can you see the greens coming all the way down into the Hudson Valley here? Have we got that one? Can you see the Connecticut Valley coming down like this in here? Okay, do you ever stop and think that we've got this pretty much natural channel going from the Atlantic all the way up to us, and how things can pretty much just kind of funnel like that? And so this is what Irene actually did. You know, went straight up the cutting edge. So, I mean, when you see it on a map like that, you go, well, of course it did, right? But it's some of those things that are critical to us, because if you live on one side of the greens versus the other, and similarly one side of the Connecticut versus the other, that's going to make a difference for you. So when I talk about topography, we can talk about it from a large perspective, but we can also talk about it from a smaller scale perspective. Mount Ellen versus, you know, Mount Philo, that sort of thing, all right? So we kind of keep that in mind, because it also influences our winds. So remember a few years ago, back in 2008, we had an ice storm in the southern part of the state that we got snow across in here. And that was, again, a classic case of understanding our topography, because if you look at it on the satellite maps, you see this kind of like dividing line that goes like this. And the folks down in this part of New England got ice, and we got snow across in here. When you look at it on a regular snowfall map, a lot of times we see that sort of northeast to southeast trend, so that we get more precipitation on one side of that line and less on the other. So again, that's the role of topography in helping to understand how things shake out. So let's talk a little bit about weather. Let's talk a little bit about climate, okay? And I'm going to kind of focus in on certain parts of things that fall from the sky, and how does that affect us. So one of the things that we're particularly interested in as growers is how much rain is falling. Is it falling in a nice gentle rain, or is it falling in thunderstorms? And thunderstorms can bring other stuff like hail, right? And they can also bring other stuff like tornadoes. Now, tornadoes, which are these lines that you see in the red across in here, when I asked, do you tend to think of Vermont and tornadoes together? Yeah, you told me the same thing as the folks on Wednesday did. Everybody said no. And why do you not think about tornadoes and hurricanes and Vermont together? Not flat enough, right? So when you think about tornadoes, they tend to occur where the land is pretty much flat, right? And knowing what I just said about topography, that is not going to be ideal for us here. But let's look and see where some of those incidences are. See this region up in here in St. Albans, Swanton region? You know how that's that flattest part there of the Champlain Valley before we get into the Green Mountains? So you see a sort of incidence across in here, and also in the Connecticut Valley in here. So any place that is particularly flat would be a little bit more conducive to having tornadoes, okay? So the green dots in here show the places where you've seen a lot of hail, and hail can of course do a lot of damage, especially if it occurs in the spring and early summer when your plants are still growing. So thunderstorms produce these things called downbursts. And downbursts, let me play that one more time for you. Downbursts, what they do is, as they come down from the cloud and they strike the land, some of it goes this way, some of it goes that way. Have you ever gone hiking in a forest and actually seen all the trees falling down one side? Mm-hmm. You've probably seen a downburst, okay? Because if all of the stuff comes down, the winds and all that heavy rain come down, knock everything this way, all of those are going to be like flat that direction, right? So you've seen some of this stuff, okay? And what it might look like is something like this. We call that straight line damage, and you've probably seen a lot of this as you go through and hike around the various parts of Vermont and upstate New York, where all of the damage occurred in this direction. Okay, so we've got this straight line damage that we can actually see. Now, thunderstorms can also produce even faster winds, and these are actually getting up into tropical storm hurricane speeds across in here. When they're that fast, they affect our trees differently. See how it just took off the top of that, okay, because of how fast it was? We can get even faster, okay? And when we get up into like category 2 and category 3 type of hurricane wind speeds, they take out the tree completely from the roots because of how strong those winds are. And so what we're looking at here is some of the damage that we've seen in the sort of largest, most severe thunderstorms that have been observed across the state. So that's in the summertime. Let's fast forward to the winter and think about icing and think about ice storms. The ice storm that you probably remember is the one in 1998. Okay, everybody remembers that one, and the sort of damage that occurred then. When we think about that particular ice storm and how severe it was, one of the reasons why it was so severe is because how long it lasted. It was like almost a week long that we got that freezing rain that kind of went on and on and on, and we came up with creative recipes, and we also became very, very friendly with our neighbors because we needed to share, right? Everybody shaking their heads. You remember all of this. But from a vegetation perspective, there's some species that tended to be more prone to being damaged by ice. And those include things like birches because of how soft they are. So there's a lot of work that was done at UVM that kind of measured how much damage occurred. And in some of these cases, the amount of ice, the 3 inches worth of ice that was on some of these branches and stems was as much as 400 times the regular weight of the trees. And so when you see some of that breakage that occurred in the post-ice storm event, it's because of the additional stress that we're looking at on the trees. So we can think about some of the other icing that has occurred and how does that affect us here in the state. So thunderstorms are huge, icing is huge, but what else can we think about from a weather and climate perspective as we're moving towards how do some of these things change? Ellen mentioned snowpack, and we know snowpack is a critical element in all of this. And when I first came here about 17 years ago and started learning about the climate of Vermont, learning about how it affects the various sectors, one of the things that I read was snow is a poor man's fertilizer. Yeah. Have you heard that? Okay, everybody's shaking their head with that one. So when we think about a nice deep snowpack, it's great from a number of perspectives, a number of sectors, not only from a tourist industry perspective, but also from an overwintering perspective, okay? So when we didn't have that snowpack last year, it was something that we actually felt. We can also think about thermal stress on our crops and how does this affect certain crops more than others? So one that I'm going to kind of just focus in on is haying. And when you think about haying, there's some conditions that are great for haying and others that are not. So cool, moist conditions are great for having first, second, third, fourth, fifth cuts, but drought conditions are not. Okay? And so when you think about some of the ideal conditions for haying, we can think about having hot and sort of dry days for harvesting, but after following nice, cool, moist conditions to get the growing going. So we have to have that nice balance in terms of our weather and climate, and how does that affect your growing. So something else that's also important when we think about specific crops is the role of frosts. And frosts are critically important at 3 times of the year: spring, summer, and fall, right? Okay, because we've got the first frost, we've got the killing frost, but we've also need to factor in frost in the summertime in there. So when we think about it, springtime frosts, the effect of them looks something like this. I had gone to the UVM horticultural farm in October. You know when they have their sale in October, and you go and you get all the good stuff, right? And so I went and I found this particular apple. So I took it up to the cashier and I said, "Is this for sale?" And he said, "Yes." And I said, "Why does it look like this?" And he said, "That's the effect of the frost that we had back in May." So it affects our tree species, and you may not see the effect right away, but at the end of the season when you start doing the harvesting. So apples are prone to frost, but they're not the only tree species that is of importance here to Vermont that's also affected. That same frost that we had in 2010 also affected things like our sugar maples and our Christmas trees. Again, something we may not sort of stop and think about, but is of critical importance to us from an economic perspective as well. So frosts tend to occur, like I said, in 3 of the 4 seasons that we need to think about: spring, summer, and fall. But we also need to think about what else is stressing our plants, and when does that occur. Now, have you ever driven by I-89 and looked at the conifers on either side, and they're brown on one side and green on the other side? What is that? That's a different type of thermal stress, and that's when you have it warms up in the winter, and so they start to photosynthesize, and then it goes back cold. And so the structure physiologically has been damaged because there's that switch in the thermal regime that we're looking at. And so there's certain conifers that are particularly prone to that. And Paul Scharberg is doing a lot of work on that to try and quantify exactly how we can look at that. So all of this thermal stress and all of this thermal pattern, we can use the plant hardiness map to actually help us with some of our choices. Do you use this when you do your selections? Sometimes. Does it work?
Not recently.
It used to work. Starkville is different. What else did I hear? It used to work until recently. Is that what somebody said? Okay. It's what?
They're going up, they're getting warmer.
They're getting warmer, so things are shifting this way. Okay. So this is kind of like a first cut, but if things need to be tweaked from a local perspective, we need to kind of keep that in mind. So what are some of these additional stresses that we can look at in terms of climate change? Well, one of the big things that we always look at is the length of the frost-free season and your growing season. And I've learned that they're not the same, right? So the length of the frost-free season is the difference between when it gets above the freezing mark, which is not the same as your growing season, which is more an accumulation of the amount of heat throughout the season. And so knowing that subtle difference allows you to understand some of these patterns in here. So what this is trying to show you is some work that comes out of the National Climate Assessment that is looking to see how can we predict some of the changes from the frost-free perspective, not the growing season perspective, okay? So let me get you situated here. You've got the outline of Vermont. Everybody good? Yeah. All right. And we're looking up here in the Champlain Valley, in this region here, and we're looking to see that there is projected to be an increase of between 25 and 27 number of days more in the frost-free. Okay, that's how we read the map. And that's for that middle part of this coming century. So about 2040, we should see somewhere between 25 to 27 more warm days, okay, from a frost-free perspective. All right, how does this translate to actual tree cover? And what this map is showing you is looking over a 10-year period, so 2000 to 2010, and we're looking to see how have trees sort of responded in the recent past to this increasing temperature and increasing frost-free time frame. And so again, let's get us situated, and we're up in here, in this region here. The green colors mean that there is an increase in tree cover canopy in this time period as things have warmed, and the brown colors mean that there's a decrease in the tree canopy. And so you're thinking, why is there this difference? Why is there this dichotomy between the two? And part of it has to do with the fact that as temperatures warm, it's not just the temperature that we need to factor in, but we also need to factor in whether that changes the ability of your plants to use carbon dioxide efficiently, or do things actually kind of slow down. And so what we're seeing here is in the northern latitudes in here, where we were able to see an increase in your canopy, but in the mid-Atlantic region in here, that increase in terms of the warming is actually causing your plants to be less productive. All right, so there's an interesting twist across in here. So let's talk about that twist. Let's talk about why is it of importance to us. So a longer growing season and warming in that growing season, what does it mean in terms of using carbon dioxide? Well, it's going to probably change the carbon cycle that is in place right now. And all of that warming and all of that increase in your growing season is going to be affected or tempered or changed a little bit by three different things. If the things are warmer and if they get a little bit drier, which is what we're seeing in the mid-Atlantic, not necessarily here, that means you're going to be more prone to forest fires, okay? And if your things are warmer, which means warmer all the way through, including your winter, less overwintering killing of your pests, so there's a likelihood of seeing more pest infestations. And then in terms of the summer moisture conditions, how summer droughts can kind of play into all of that. So warming is not just by itself, it's also with these additional factors that we kind of need to sort of keep in mind in here. So the question is, are we susceptible to drought?
Yes.
If I had to do a poll in here, are we susceptible to drought? Yes. Most say yes, some say no. Not very, sometimes. Anybody else? It all depends. All right, let's throw maybe into that equation too. All right, so let's see if the answer is yes, maybe, or no. Okay. This is what drought looks like in Vermont. On the left across in here is some corn from the drought of 1999, and I don't know if you can see that. You see the leaves completely brown. This was in September, mid-September, by the way. The corn was this big,
Yep.
and it was black. All right, and if we fast forward to the 2002 drought, this is what it looks like. This is, do you see the leaf scorch on your sugar maples?
Yes.
Okay. I don't know what species this is, but you also see leaf scorch across in here. And then this is what we can see in terms of forest fires, brush fires in Rutland and for the 2008 drought. So one of the reasons why I'm so interested in drought is you hear there's going to be more droughts as part of climate change, and they're going to be worse than ever. So what I wanted to do is to go back and figure out what is the worst drought that we've seen in the state of Vermont. Okay, does it look like this? It's actually worse than this. The worst droughts that we've seen in the state of Vermont are 4 to 5 years or longer when the wetlands dry out to the point that they start to burn. Do you know how much it takes for a wetland to burn? Okay, because wetlands are part of the integrative part of our system, as Tom mentioned back on Monday, right? And when we think about wetlands drying to the point that's not just the standing biomass that's burning, but it's also the subsurface that's burning, Okay, the root zone, that's also burning. That's how dry we've gotten. Okay, so when we think about the worst droughts on record, these are not close. They're sort of like mid-range in terms of what we can actually see. So let's talk a little bit about drought so we have a perspective on it. When we see some of those droughts that are like 4 or 5 years, those are droughts that are over a very large extent. So like they're the entire state, and they're probably all of northern New England being affected. Okay? So they're long and they're big in terms of extent and time. Most of the other droughts that we'll see are actually shorter. And some parts of the state are more prone to droughts than others. The southern part of the state is actually more prone than we are in the Champlain Valley. Okay? So the southern part of the state actually tends to be in drought more often than either the Northeast Kingdom or the Champlain Valley does. All right? So there's a difference in terms of that. So when we talk about drought, we shouldn't talk about the whole state because it's going to differ from one region to the next. Now, the other thing about drought is it can occur every single season. So that includes winter, right? If you don't get precipitation in the winter, that's a drought as well. How do you see that? Like little snow. Who's going to be affected by that? Ski industry. But it's also going to affect us as growers because there's that snowpack that we need to kind of factor in as well. So that's some of the things that we need to think about. And so what we're looking at here is 2 different seasons. You've got winter and how the precipitation has fluctuated from 1895 to the present. And this lower one here is summer. And right off the bat, you'll see that winter and summer don't look the same in terms of their pattern. Okay, so that's one of the reasons why we need to kind of tease out that seasonality perspective that I mentioned before. All right. Now, last thing on here is, and this is characteristic of Vermont, we can go from a drought to a flood in the same year and in the same month. Right? You know Hurricane Irene? Hurricane Irene was actually preceded by a drought. So we had the Lake Champlain flooding in April and May. And then we actually dried out enough to be in a drought, and then Irene came along. So if you only look at the whole year, you would have never known that we were in a drought. And I was actually working with the emergency management folks to do a disaster declaration for drought before Irene came. Okay? So this tendency to go between floods and droughts looks something like this. This is as of last night. And this is the Lake Champlain levels for 1st of January up until right now. So the purple line here is the level that's been measured for all of 2014. All right? The blue line here is the highest that the lake has ever gotten. And this is the 2011 flooding. This is Irene down in here. Okay? And this down here is the 1927 flood. Flood of 27? Okay, right. So we got our 3 markers. We've got this one, our spring flooding, we've got Irene in here, and we've got the 1927 flood. So that's the highest it's ever been, okay? The green line down in here is the lowest that it's ever been. And that includes years like 1909, okay? So now that you've gotten situated, let's look at 2014. 2014, we were actually sort of chugging towards, see how dry we were? And then remember the National Weather Service put out a forecast for potential for flooding. And in the space of less than 2 or 3 weeks, we went from being almost as dry as we've been to almost approaching those 2011. So when I say to you floods and droughts in the same year, we've seen that this year. Okay? So we need to continue to look at all of these different factors together to get the full picture of what we're looking at here. So forgive me for this slide. Look at me instead. I'll talk you through this slide. And it's, why do we need to understand drought from a growing perspective? So you know when you don't get enough precipitation, that's one way of looking at drought, right? And that's what me as a climatologist would be looking at. So that's called meteorological drought, when you don't have enough rain or snow, okay? Now, when that lack of rain or snow starts to affect the shallow-rooted vegetation, like your grass, you know your lawn, and you see it starting to brown up a little bit, then you know you've moved into the second type of drought, which is agricultural drought, Okay, and that takes a while. It takes like about, you know, a couple weeks to a month to start to kick in. But when that goes on for more than 2 or 3 months and you start seeing the lake levels dropping, you start seeing the Winooski dropping, you start seeing your wells start to drop. Now you're talking about the third kind of drought, which is hydrologic. All right, so there's a lag going on, and we need to care about each part because it's going to affect us, especially if we do things like irrigation and so forth, okay? So this is to show us the sort of end result of why do we need to think about and care about drought. So when you think about when it occurs and which species are affected, do you know that most of the color in the fall is from sugar maples? It's not from stuff like Norway maples, right? So if your sugar maples are affected by drought and you get that leaf scorch, that's when you see, you know, that kind of yellowy color in the fall. It's not, I mean, it's there, but it's not the greatest in terms of pictures. That's the effect of drought on your sugar maples, okay? When there's a perfect year, this is what your sugar maples look like. This sort of vibrant orange, reddish type color because they were not moisture stressed, all right? So knowing when that occurs is going to be of importance to different parts of the economy. Now, the last thing about drought, and this is what you should probably all make a note of, why we should care about drought, it's because it affects the ability of your plants to absorb carbon dioxide. And so this is one of the reasons why when I ask you, are we susceptible to drought? And we now are going to say yes. And do we care about drought? And we'll all now say yes, right? Because it's going to affect our plant's ability in terms of its yields, all right? It's also going to affect all of the carbon loss from the soils that are taking place. So there's a sort of feedback to looking at drought and to understanding it and appreciating it when we have this in our system, okay? So that's one big piece in here. Alrighty. So Vermont is complex in the sense that we can have stresses that are going on at the same time that are affecting different species, but they're all either interrelated or not interrelated. So here we go with some more leaf scorch in here, okay? Here are my Norway maples with that tar spot. And you know what tar spot means, right? It means that you had a wet summer that year, or the previous year, or the previous couple years. So this is actually a kind of lag system. So when you see a lot of these tar spots, it's because it's excess moisture. And that excess moisture could have been the year before. Now, when you think about Norway maples, and because when I first saw this, I contacted my friends at the Forest Service and I said, is this going to affect the fall foliage? And they said no, because Norway maples, when they turn yellow and they're not contributing to the fall foliage. So we can look at infestations, both fungal as well as insect-based, including tent caterpillars. Do you know tent caterpillars? Yeah, right. So tent caterpillars are really, really, really pronounced during drought years. Okay, so again, there's that connection between what we're looking at and how it sort of affects us, so that in a drought year, it's not just, you know, affecting your plants, but it's also being conducive to infestations like your tent caterpillar. All right, there's sometimes I trip on these words and they don't just come out right. All right, so let's, with all of that as a background, let's see how we can talk a little bit about climate change. And when we're talking about this is the second slide I'm going to apologize for, because this is what you never ever do, put so many words on a slide, but I always do it and then I apologize for it. So let me put this up here because it's how does the International Panel on Climate Change, the IPCC, which you've probably heard about, how does it define climate change? And I'm going to direct your eyes. They're a little bit in bold here. The bold is my emphasis. And when we're talking about it from a climatologist perspective or a meteorologist perspective, what do we look at when we're looking at climate change? We're looking at changes in the average values or changes in how variable things are. And we're looking at that, and this is a kicker. It has to be over decades for us to talk about climate change. And when we're looking at it both from a human perspective, but we're also factoring the natural variability, especially in a place like Vermont where you've got so much variation kind of going on. So let's see what some of this kind of shakes out to be. When we try and look at what that change in the mean and change in the variations look like, there are 4 ways that we can look to see how climates can change. So we can see this sort of periodic stuff, or we can see these big jumps in the record. Okay, we've seen that in the past. Or this is the one that you're probably most familiar with here, where, you know, when temperatures are either increasing steadily or decreasing steadily, a trend. But the one I kind of like to kind of focus in on is this one here. Do you see how these squiggles are getting bigger and bigger over time? Okay, why is this of importance to us? You know, we as a species, we as a society, and I don't mean only in the US, as a society globally, we're sort of adapted to living within certain thresholds, right? And then it's once we get outside those thresholds, that's when it sort of exceeds our ability to adapt quickly, okay? So when we think about these thresholds, which are these red lines that I've drawn in here, and we think about more heat waves, more cold waves, more droughts, more floods, how do we use that to help us with our adaptation, okay? So that's what they mean when they say changes in variability. So let's talk a little bit about that, because like I said, it's very, very germane to us. Now, if I ask you, what was the word of the winter this year? The one that everybody was buzzing about? It's amazing. Everybody says that. Cold, ice, long, darkness. Getting tired of it already? Yeah. Okay. Polar vortex. Yeah. Remember back in January, that was the word that hit and everybody was like, polar vortex, polar vortex, polar vortex. All right. And when you think about the polar vortex, it has this sort of shape to it in terms of how does the jet stream kind of meander back and forth, and how do we get stuck in one part of the jet stream, and how does that getting stuck cause us to get all that cold air from the poles, right? Last year we got stuck, but we got stuck in the warm part, so we didn't get any snow. Okay, so last year's word was Arctic amplification. It's all part of the same process. Okay, and so we're looking to see how does that change, because it's going to affect things like where my storm systems move. Do they move north or south? And it's also going to affect things like how much snow we get and when does it fall. So here's a quick way of looking to see that shift in storm track. So we got 2011, 2012, 2013, 2014. And they're all pretty much the same date, because what I wanted us to do was to compare it apples with apples, okay? And so you'll see, like in this case here, all of your storm systems are pretty much north of us. So that's where the heaviest snow was for this particular date in February, right? And then in 2013, last year, we were still getting less than what we would usually get here in the Champlain Valley, and this is 2014, before we got the March snowfall that shut us down again. Okay, so that would have been yet an additional piece across in here. So one of the ways that we see this variation is something called a backward season. And I thought I had found something new when I was going through this, but somebody in the 1800s beat me to it. Because backward seasons were discovered back then. And what does it look like? A backward season is either late for that time of year, or it's going in the opposite direction, okay? So we've seen a number of these backward seasons in the last few years, and they tend to be associated with cold air coming from the northwest and kind of hitting us. You also see a lot of frost, and you see snow. So these are pictures taken at UVM in April 29th. What's today, the 26th? April 29th, 2010. And it shows some of that snow that actually fell. I know you don't want to hear this, do you? Okay. All right. So last month was particularly cold. That's the first word you said to me. It was so cold that on the National Climatic Data Center, when they put these maps together for all of the US, we actually got special mention. So Vermont had its coldest March on record, which means since 1895. So March of last year, last month, March, was coldest on record since 1895, and its temperature was about 8.9 degrees below average. Average. Okay. So let's think about climate change as a system. By now, you're probably starting to see how I like to put all the pieces together, because if you miss one, you're going to miss part of what's going on. So let's think of it as a complex system that has things like, you know, precipitation falling, it has moisture moving, it has temperature warming up the atmosphere, it has things like infiltration, it has glacial melt, it has all of these various pieces going on back and forth across in here. And so when you think about it, and you think about how climate change, work with me for a sec, don't try and read that diagram, even if you can. See if this makes sense. If you heat up the land and you heat up the air is going to start to move, right? And if the air starts to move, then the wind patterns are going to change as the air moves, right? And if the wind patterns change, your storm systems are also going to change, right? And that's going to affect who gets rain on Ellen and who doesn't get rain, right? And whose soil is going to dry out and whose soil is going to be waterlogged. Are you following me here? And so when we put all those pieces together, then it becomes this intricate system where you can't leave out a piece, otherwise you're going to miss part of that jigsaw puzzle. And that's what this diagram is trying to show you. All those, you know, arrows going back and forth in both directions are trying to capture all those various pieces that I just walked us through in here. So I like to think of different pieces of the climate change conversation as whether we're talking about the process by which climates are changing, or if we're talking about changes in terms of the impact, so like changes in bird migration, changes in the bee population, changes in your phenology, all of those are your impacts in here. And then what are some of the strategies that we can implement either from a mitigative perspective or an adaptation perspective to work with climate change, okay? So we can think about it as a sort of continuum. Now, this diagram here comes from Natural Resources Canada, and it kind of has a nice way of showing the winners and the losers from a growing perspective. So across in here, we have things like the possibility to grow new crops, and I'll talk about that in a sec. But then we also have the sort of losers in terms of the increased pest infestations and so on and so forth. So it's a very nice way of keeping both sides of the conversation kind of going across in here. So let's talk about greenhouse gases for a sec, because that's one of the drivers of climate change. Now, greenhouse gases include carbon dioxide, methane. Anything else? Hydrofluorocarbons, okay. Anything else you remember? Nitrous oxide. And then one that we always forget, that's critically important to us as growers. What was that? Who? Okay. I'll just show you what it is in a sec. So the ones that you just mentioned to me, yes, H2O, water vapor, yes, we always forget that one. Carbon dioxide, methane, the chlorofluorocarbons, your nitrous oxide, all of those in there that we need to think about because they're critically important to us. But this is the one we always forget, ozone. Ozone, at the levels that we walk around at, that's what I mean by ground level, ozone is also a greenhouse gas. Now, why do we care about ozone as a greenhouse gas? Well, we care about it from a human perspective because it irritates our lungs, but we also care about it from a vegetation perspective because it affects plant growth, it affects seed production, it affects some species more than others, and that includes things like your black cherry, white ash, and yellow poplar. So ozone at the ground surface is important for us to factor in. Fortunately, it doesn't last as long in the atmosphere as some of the other greenhouse gases do, okay? But it's still of importance to us. Now, we have 2 sites in Vermont that we measure ozone at, and so what you'll see is that from 1995, the amount of ozone at these 2 sites has been decreasing, which is a good thing, both from a health perspective as well as from a growing perspective. But the injury looks something like this. And I'm going to apologize in advance for this slide because I was told that milkweed is this one and yellow poplar is the other one. That's what happens when you borrow slides. Okay, I didn't put this slide together, but I always have to point it out now that I know the difference between the two. Okay, alrighty. So let's kind of take this all home and think about some of the projected changes for the Northeast as a whole and for Vermont in particular. Now, notice the bigger font on this one. So when we think about how climate is projected to change in the future, we can think about it from what they call the near century, so 2035, which is not that far away. We can think about it from the middle part of the 21st century, and you can think about it from towards the end of the 21st century, okay? That's how it's kind of broken up. So for the near part of the century, some of the things that are being projected is that the change is not going to be larger than what we've seen in terms of year-to-year variations. And that's why I spent that time talking about what does variability, what do variations look like. So we know what they look like and can use that in terms of our planning. So variations, again, bringing in that seasonal perspective. This is for the Champlain Valley region. We've got the winter time, we've got our spring, we've got our summer, and we've got our fall. And you'll notice, you see this? Yeah. Every time it's green, it means above average. Every time it's brown, it's below average. So you'll notice that whatever's going on in the fall is more and different than what's going on in, say, the summertime or some of your other seasons. So again, when I first showed this last year at the NOFA conference, and I asked, does knowing the timing and some of these changes make a difference? Folks in the audience shook their heads because it allows you to make informed decisions in terms of either choices or timing of getting things into the ground. So one of the other ways of looking at some of these projections is those intense rainfall events. How are they projected to increase, or how have they increased? And so again, we're starting in 1895, going up to 2012 across in here, and we're seeing these increases in terms of that heavy precipitation over time. And when they do analysis to see is this statistically significant or not, this line that's drawn on here is actually not statistically significant. So the increases are there, but they're not statistically significantly so. So how about the middle part of the century and the end part of the century? Well, in those cases there, what we can say is that your precipitation is going to increase. Okay? So there's no more, looks like regular year-to-year variations. We're talking about increases here. Now, the amount of the increase is what we're still trying to figure out. There's still a little bit of uncertainty because of the amount of spatial differences across the region itself. So if we look at days when we have an inch or more, so in other words, days with heavy precipitation, what you'll see again, let's get us situated here in Vermont, up in this region here, at least 20% increase in that 1 inch precipitation that we're looking at in that time frame in here. The flip side of that is the dry days, so days with less than 0.1 of an inch, and you'll notice that there are fewer dry days up in this region in here, okay? All right, so if I had to put some numbers on these changes that we've seen over time, this is winter, December, January, February, this is spring, this is summer, and this is fall, and these are the changes over the time period. So again, there's that fall kind of showing you it's getting wetter than the other seasons. So again, this has implications for us here in the state. One other way that we can look at changes in precipitation is, you heard of the 1 in 100 year event? Okay. We can look at that change in the recurrence, change in how often things are expected or probability of occurrence. And so something that used to be a 1 in 100 year event is probably going to be a 1 in 60 year event. So the recurrence of it and the size of it will actually be changing. Okay? So this says the same thing as I just said across and in here. And this one actually is important to us here, because something that was a 1 in 50-year event like 40 years ago is now going to be a 1 in 30-year event, because that precipitation has been increasing over the last 100 years or so. Okay, so one other way of looking at this, to bring all of those last 4 or 5 slides together, is the change in precipitation in terms of an increase or a decrease. And you see those increases in winter, which are more than spring and the fall, and decreases in your summertime. So blue is increase and brown is a decrease. Okay, so if we put all of the many things that I've just talked about together all in one place, let's see some of the sort of take-home messages that we can look at. I'm going to start with topography. Topography is absolutely critical in terms of understanding the various places across the state that we've looked at, and that helps to feed into spatial variations and temporal variations being important. One thing that I haven't mentioned but I've alluded to is we're pretty much at the exit of a lot of stuff, right? A lot of storm systems that move to us from all over, and so when we talk about Vermont, we talk about understanding our patterns, we still need to keep an eye on what's going on continentally and regionally across in here. All of this is not linear. It has all those feedbacks that we just talked about, both atmospherically, but also how do they all affect the plant population and the pest population. And then something that we need to keep in mind is some of these impacts that we are looking at or expect are going to be species specific. So that's one thing to kind of keep in mind, so that if I had to make one suggestion, and I know we do this anyway, but maybe to have it at the forefront of our minds as a conscious choice, that flexibility in terms of both your selection as well as your timing is going to be important. It's going to be a little bit easier for some types of things that are planted than others. Your tree species are going to be probably among the harder, because those take a while to mature. But just to keep those in mind, and to keep in mind the seasonality that is critically important. So with that, I'd like to wrap up and take some questions. Please feel free to email me and ask anything that you didn't get to ask or not going to ask right now that you'll ask. Think about as you're driving up the Intervale Drive. Please feel free to email me at that point, okay? So, questions?
I have one. I need a definition to understand something a little more clearly. You said that 1 in 100-year events would be 1 in 60 events. It caused premature destruction of the infrastructure. What is infrastructure exactly?
Infrastructure, in that case, they're probably talking built infrastructure. Okay. So transportation, buildings,
okay.
Urban.
Okay.
Yeah.
Okay.
Tom?
So that argument back with poor man's fertilizer, is there truth to, I mean, and both of those people who were doing, Hub Vogelman and Win Wei were the people that were having that debate. They both passed away in the last couple of years. I just wondered, was there any truth to that?
I think there is. I think there is, because if we think about all of the sort of spring and summers that we've seen in after winters that had very low snowpack, you tend to see more damage occurring. And so I think there was some truth to this deep snowpack being poor man's fertilizer. And I also see it in the historical record, because there's something about the snowpack and the ability to tap earlier and longer when you have a deep snowpack than if there was less, even if your temperatures are perfect. So again, there's that, when you think about species, you can't only focus in on one thing. And so sugaring is a great example where I would say most definitely that was true. Yeah, because I've read records that people were tapping in December, as long as the snow was deep enough.
So,
Go ahead.
so fertilizer in that context doesn't mean more nitrogen, it means
No.
better productivity.
Right.
It's a metaphor.
Right. So the question was, fertilizer in that context doesn't mean nitrogen, or what was the other one?
Metaphorically,
Right.
it means it's better.
Right.
But not
So-
necessarily because of nutrients.
Exactly. So it's not a nutrients in terms of phosphorus and nitrogen. And, yeah. It's mulch. Yeah, that's probably a good way of thinking of it. Yeah, mulch. There was a question in the, was it you?
No, I didn't. I I grew up on a farm, and my father is 89 years old, and that was one of his expressions. Oh, this is going to be good, and I always thought it had something to do with the nitrogen, because after you get a late snow and it covers everything comes up green, really, really green.
Interesting. And
So I think there is something to be said about nitrogen being in that late snow.
And just to paraphrase your comment for everybody to hear, you grew up on a farm, and your father always said about earthwise,
Whenever we had a late snow.
and how late was late?
In April.
So a snow in April. And do you remember any decades in particular?
Well, that would be in the 60s.
Okay. And so there may be some truth to the nitrogen part in there. You know, I think that would be a great master's project. No joking, because I don't think anybody's actually explored the physics, the processes.
I'm going to ask my father tonight. See him, and I'm going to ask him what he meant.
That's perfect. That is
That's
perfect.
an expression that I've heard.
Yeah, but you know, all of these expressions are all true because there's always a physical basis for it. It's like when the mountain roars, close your doors. It means there's a storm coming through, and you know the winds higher up sound like a train coming up, right? And so there's always physical truth to all of these expressions. So there was a question over here and then across here.
Well, a question back on the snow cover. Does the insulating quality of snow prevent the frost from going so far deep? Does that contribute to a better crop, or part of the reason that it's considered
Right.
It's not really, it may not be a fertilizer, but is it something that just simply improves growth, and is it because the frost didn't go down so far?
So the question was for everybody to be on the same page, if it's a question of the insulating properties of your snowpack, and I would think that there's some merit to that too, because if you think about current practices in Florida when there's a freeze coming through, what do? They go out and they spray the crop, and so what does is it freezes on the outside, and the crop inside is protected because the heat loss isn't occurring. And so there is merit to that insulating part of that as well. So I would definitely say yes. And there's another question over here.
Right, to do with the, I don't know about the fertilizer thing, but my dad always plowed in January when we got snow.
Wow.
You know, after the thaw,
Yep.
and then we got that first snow.
Yep.
That's when he would plow.
Cool.
Oh, interesting.
I've never heard that one before. And any anecdotal evidence on the
I don't have a
yields?
clue, but I just remember that. It's a 4-man fertilizer.
Yeah.
Now it is.
Interesting.
I don't do that.
Oh, I was just thinking about the snowpack, and the reason why the growing season is really good afterwards is that maybe it traps the nitrogen that ordinarily would be evaporated.
Mm. Okay.
That's a theory.
You know, if I could tap the expertise and knowledge and all the comments in this room, I think we could get a really good thesis out of this. I am dead serious. Yeah, I'm dead serious. So when I go back and I look at this film, I'm actually gonna try and remember all the names here, because I'm gonna be coming after you, so that you can tell me all these things one more time, so I can actually, you know, get somebody. And Rachel's probably standing in the back there thinking, no more projects. But she might have somebody in mind. Okay. One last question. Oh. Okay. Yeah.
Go ahead, Donna. Oh, me?
Yep. Go ahead, Donna.
Sorry. Well, I'm the skeptic among you, so don't burn me at the stake. I lived through the most recorded rainfall back in 1999, I believe it was. And I attribute that, I really thank God for that, because my husband proposed to me during that time. So how do you say that, okay, so there's between the most recorded rainfall in 1999 from 1895, I guess people started recording
Right.
things. How can you say that now that So now we're gonna have it, instead of being once every 100 years, it's gonna be once every 60 years, or however that goes. I mean, I kind of go by a lot of, you know, like a lot of farmers' almanac things that are very outdated and old-fashioned, but that have had a lot of merit.
Right. So I think there are two ways to answer your question about the heavy rainfall in 1999 and how that kind of factors in. One of them is the fact that heavy rainfall in 1999, was it associated with either Floyd or Dennis in September?
I don't believe it was in June.
When was your
It was
proposal?
in June.
Okay. It was in June? Okay. So if it was in June, I'm trying to think back to 1999. I know the heaviest rainfall in depends on where you are in the state too. Because the heaviest rainfall that year was 14.5 inches on top of Mount Mansfield when Floyd moved through. So if it was in June, it might have been like a very localized thunderstorm. But the other piece of your question was the 1 in 100 year. So 1 in 100 year means that there's a chance of that occurring. It's not that it only occurs once every 100 years. So it's a probability, it's a statistical way of talking about it. So you can actually have a 1 in 100 year event occur a couple times in a year if the conditions were right. So there may be some of that also went on in there. Does that help with? Okay, perfect. And then Joe.
When we were watching the weather, especially in January, with all the polar vortex dipping down, I was looking at the television, and the maps just showed the northeast U.S. and southern Canada, and I was wondering if that cold air is coming down to this side of the globe. Is warm air rising up on the other side? What's going on as a planet?
Right. So Joe's question is about the polar vortex, and the polar vortex affects the jet stream. So you know the jet stream does like this, and it goes around the Earth. So yes. So if somebody's getting a dip in the jet stream, chances are the neighbors on either side of them are getting, the opposite of a dip, kind of like a ridge, right? And so the thing about the polar vortex is that the difference between the Arctic and the mid-latitudes, instead of it being really, really steep and keeping all the cold air in the Arctic, now it's like this. And so the jet stream dips down further and comes up further and dips down further. And so that's why you tend to see, like so much cold air getting all the way down to Florida and Texas this year because it dips so far south.
So the implications for the polar ice cap?
So the polar ice cap is probably still going to continue to melt because of the processes that are in place up there. But the net result is not increased warming everywhere because it's now affecting the upper parts of the atmosphere where the jet stream are, and that's that feedback. That's that many pieces of the jigsaw that I was talking about. Okay, last question.
One more.
One last question, otherwise Rachel will not be able to give hers.
I just had more of a comment touching on Joe's question. If anyone was following the phenomena of all the snowy owls that were in Vermont this year, and even south of Vermont, which I'm from Vermont, I've never seen snowy owls in Vermont. So up north, I think it was because of an explosion of their food sources, being warmer up there, and then pushing, the baby snowy owls further south. So just watching the animals coming down, the birds, and I think they found snowy owls as far all down the East Coast. It was very unusual, but in Vermont,
Interesting.
it was fantastic to see them.
And on that last comment, I'd like to thank you. You've been an absolutely great audience.
Thank you, everyone, for your attention, and thank you, Ellen, for the invitation to come and speak with you all. So my name is Rachel. I am a farmer, and also I'm a PhD candidate at UVM in the Plant and Soil Science Department. Ellen asked me to speak today, I think partially because climate change is something I think about in my business as a grower, and also the topic of the research that I'm doing for my degree. So I thought I would start out and tell you a little bit about the farm. And because you all are growers yourselves, I didn't feel too terrible about geeking out on some of the soil information. So as I lay the story, we'll go over kind of what soils I'm working with and what we're growing and things like that. I started the business in 2009 at the Intervale here as part of the Farm Incubator Program. Are you all familiar with kind of the context of that program? Briefly? Some yeses, some nos. In short, it's a great incubator program where you can lease land, you can share equipment, you can share greenhouse space. It's a wonderful way to get a business off the ground with without a lot of capital investment. As people probably know, it's also has some downsides to it. Farming in a floodplain is never an easy thing. When Leslie Ann was talking about how topography makes a really big difference for growers in this state, she wasn't kidding. We decided to transition the farm out of the Intervale. 2010 was our first growing season at our current location, which is in Moncton, about a half hour south of here. Completely different soils, completely different growing experience, which I'll talk about a little bit more in depth. We're a certified organic vegetable business. The farm where we're at has a long history of agriculture. It was part of the Rotax dairy farm, which the Rotaxes came over from Germany and settled here in the 1700s. At one point, they had about 800 acres of land that they used for a dairy herd. Our barn was built in 1908 and was the last building that they used to milk a much diminished herd of Jerseys up until the 80s. So we have two types of soil that we work with. Marlow loam, which is a glacial deposit. It's full of rocks. It's also wonderfully well drained, very fertile, beautiful consistency. I really love working with it. That's about half of our growing space, and the other half are different degrees of mix between Marlow loam and Virgins clay, which for those of you who are in Addison County, you know what I mean. Pretty much we grow on one field primarily. It's almost all entirely south-facing, 3% slope. As I mentioned, very well drained. It's kind of ideal. I looked for land for about 6 years before purchasing this property, and I didn't find anything that was quite so lovely, that was within a reasonable distance of Burlington or Montpelier, which were the markets that I was trying to reach. We do have a deep well. We use drip irrigation, which is important kind of in the context of thinking about climate change and how it affects growers. And we are powered with 4 solar arrays at this point. We're a very small farm. As I mentioned, I'm part-time. Well, actually, I'm a full-time student and a full-time farmer. But I do have 3 employees, which is really great. 1 full-time, 2 part-time, and they're a really fabulous team. This is a map that a UVM class drew for me last year when they were doing a research project on the farm, and I just put it up there to kind of show that the field is really broken up into several plots, and this is a couple years old, so now we've got, like a couple more hoop houses and what have you. But I do practice crop rotation. I really believe that kind of managing fertility through green manure is really beneficial for my farm, especially considering the cost of fertilizer and inputs, but also just for basically maintaining soil health over the long term. We try to leave cover crops on for at least 1 year to have both the effect of building fertility and significantly contributing to the organic matter content of the soil. And I love it. I love kind of playing with the cocktails. Like, ooh, are we going to put Sudex on this year and vetch in the fall? Or it's like a little logic puzzle. Most of my product is sold in the Burlington area. I'd say we do about 1/3 of our sales through the Burlington Farmers Market, 1/3 through the Intervale Food Hub, which is a multi-farm CSA that delivers to a lot of workplaces. And then about 1/3 through a combination of restaurants and institutions, including Wake Robin, which is one of my biggest partners. I sell wholesale to their kitchens and then also run a CSA for their staff. As I mentioned, we do veggies. We've kind of been playing with this arc of what diversity of plants to grow makes sense. The greater the diversity, the more I want to cry in July. But it's nice to have the right mix for our markets. So when we started, we actually started only growing basil and garlic. And we made a dairy-free and a nut-free pesto, which we still produce and sell. But since 2009, when that was our main product, we've expanded to just do a very wide range of summer vegetables and have been playing around with season extension by doing some winter greens in our hoop houses. So we do. This is our other crop. It has a lot of implications for our farm. It's really hard on machinery. We spend a lot of time picking rocks. But I put it up there kind of to show that it's a trade-off. We get a lot of benefits from being on this particular piece of property. This is the drawback. The biggest benefit is that we don't have to watch the flood gauge with quite so much anticipation and fear. My last year at the Intervale was the year of Irene. And which is, you know, it's interesting when I say that, it really wasn't Irene that got us. At that point, we were still doing mostly basil and garlic, and really most everything was out of the ground. What got us was the 12 weeks of heavy rain and flooding in the spring. When you have a planting period that's only 16 weeks long and you lose 8 of those planting weeks, you're in trouble. So I kind of I just say that not to paint the Intervale as the worst place to farm ever, because it certainly isn't. You know, my friends who are down here now farming have been planting for 2 weeks. I'm still waiting for my fields to dry out, even though they're really well drained and there's no chance they're going to flood anytime soon. There are pluses and minuses to each location, and I think about that a lot. I think what makes my experience very different in each location is really how I manage water. And because we're still so new on this piece of land, and I'm still figuring out how to deal with kind of the engineering of an irrigation system, this is where I see my biggest learning curve to be as a grower, in the context of climate change and otherwise. So I'm going to transition now into talking a little bit about my research and the work that I do with UVM. As I mentioned, kind of the overarching theme of my work is how climate change affects farmers in Vermont and what farmers are going to do about it. There are a couple different projects that I'm working on that fall under that theme. The first one, which applies to both my research and my life as a grower, is this issue of spotted-winged Drosophila, or SWD. So how many folks here are familiar at this point with SWD? Okay, so because not everybody shook their heads, I'm going to just spend a few minutes on it because I think it's going to be something that you as master gardeners are going to really want to know about. Spotted-winged Drosophila is a type of fruit fly. It's new in the US as of 2008. It's new in Vermont as of 2011 or 2012, depending on where you are in the state. It is considered an invasive insect. It falls under my purview when I think about climate change, not because we can make an easy connection and say, this pest is here now because of climate change. It's more that trends that we are seeing that we think are related to climate change affect this insect's life cycle and therefore the degree of impact that this insect is going to have on our crops. What crops, you say? Fruit, berries, strawberries, raspberries, blueberries, blackberries, anything that is sweet with a soft skin. And the reason it's a problem is because the female, right here, has an ovipositor that has 2 rows of very sharp teeth on them. Unlike most fruit flies, which have a blunt ovipositor that's generally much smaller and they can only lay eggs into compromised fruits that are already rotting or that already have some disease, spotted wing Drosophila can lay their eggs into fruit that is just ripening. Looks pretty good. And they can lay a lot of eggs. So the result is that you have a fruit that actually looks quite whole on the outside, and on the inside you have a lot of larvae. And because this is a fruit fly, and because their population builds very quickly, they can go through many, many generations in a season, you end up in a situation where later in the fall especially, you have this enormous spike in population, and fall ripening strawberries or raspberries are seriously compromised. This has obviously implications for gardeners. My attention has mostly been on commercial growers. There are some management options that people have been experimenting with. Spraying, there are lots of pesticides that you can put on there. The most effective ones are systemics, which I have my own opinions about. But they're very expensive. And for pick-your-own operations, and even for regular not pick-your-own operations, there's the lag time where you can't enter the field for a certain period of time after you've sprayed them, which has consequences for your ability to even harvest the fruit in a timely way. Some people are picking underripe fruit, which doesn't necessarily eliminate the damage that the insect is going to cause, but it does minimize it. Refrigerating fruit helps, freezing fruit helps, but again, these don't kind of like the larva is still there, it's just how quickly is it going through its life cycle. Customer management, we have kind of anecdotal stories of a grower in Rhode Island that basically just tells his customers, like, look, here's this pest, take your stuff home, put it in the fridge, put it in the freezer, do not leave it on the counter, and people seem to be relatively okay with it. I don't know how that would work if you weren't in kind of a direct market, farmer directly to consumer situation. Because basically what will happen is if you have like a pint of raspberries that are infected and you leave them on your counter overnight, you're going to go from having a beautiful looking basket of raspberries to a puddle with things in it. So, so not to scare you, my work that I'm doing is specifically on exclusion netting. So I want to see what the most cost-effective way is for specifically organic growers to manage this pest. And exclusion netting does seem to be the most kind of hopeful thing, and we did some preliminary trials last summer that showed that of a certain size, insect netting with openings that are smaller than 0.98 millimeters are effective, but we want to establish the scientific validity or the statistical validity of that finding so that we're doing a more rigorous study this summer. But I also want to know what effect that netting has on the crop. Does that mean that it's going to be a little bit hotter underneath the netting? Is that going to affect the ripening? Is that going to affect any kind of pollination if there's staggered pollination? So there are some things that I'm playing around with in terms of what the effect of this particular management strategy is going to be. I also think it's going to be way more practical for gardeners. When we're talking about people with a 4-acre field, how are they going to manage to enclose something in a way and still be able to manage the crop? So the hypotheses are that the exclusion netting is going to be effective, that it'll decrease the amount of damaged fruit, and that somehow the plants are going to be affected. For those of you who are interested in seeing if you have this in your gardens or in gardens of other folks that you work with, the traps that have been developed that are most effective based on the colors that the insect is attracted to and kind of the chemistry of the baits are really simple to make at home. And you can find a recipe actually for the bait at this website right here. Yep, I can read it. Sorry, it's www.uvm.edu / from VT veg and berry So this is Vern Grubinger's website, /SWD /2013 _ SWD _ trapping. This is gonna,
Can you just do a search for
you can do a search for SWD Vermont Veg and Berry and you'll find it. So this is basically a solo cup, a big picnic cup. I actually bought these on a UVM credit card last year, and I had the Associate Dean of Extension call me and be like, so I know this is probably legitimate, but it looks like you were shopping for a picnic. So red solo cup, black electrical tape wrapped around the outside, small hole punch. This is smaller than a normal hole punch. It's 1/8 of an inch, which you can get at like crafting supply stores or online on Amazon. Inside is a smaller vial. In the vial, you put a mixture of yeast and sugar and water. Cover it with some screen that's too small for insects to get through, like window screen. Just cut a small circle and put it on with a rubber band. And then place that in the cup and pour around it a mixture of apple cider vinegar, a little white wine, and a drop of dish soap. Yep. In the lab, we use ethanol. You can use cheap white wine. And then when you hang them, you have to cover them with a lid. You have to hang them under the canopy because the insects really don't go to the cups if they're out in the broad sunlight. And what this is going to do is this is going to tell you if you have them or not. It's not going to really be a good indication of how many you have because we can never really tell how many are going into the cup versus how many are just like hanging out in your raspberries. But it's a good start. They are very, very difficult to identify by sight without a hand lens. You can send them into Margaret Skinner at the UVM entomology lab, but the best indication is to look for the males, which have this spot that is bisected by the first wing vein. And then you can also see on the front of their legs, the front legs have 2 black stripes going through the different tarsi. So since it's a fly, there are 5 tarsi, and it has 2 black stripes on the front. Okay, different project. The work that I was actually hired to do as a PhD student was to work with this broader effort called the Vermont Agricultural Resilience in a Changing Climate Initiative. Quite a mouthful. And I'm going to just take the rest of my time to kind of tell you what we're looking at, what it's about, what we hope to get from it, and then I'll leave the rest of the time for a few questions. So it's a big project. There are lots of UVM people involved, which is this slide. My point person, my faculty advisor is Ernesto Mendez. He's an agroecologist. He specializes in looking at coffee systems, actually, and biodiversity, but he has been working more in Vermont, trying to really identify what are the big problems that Vermont producers are facing, and how do we use an approach that involves bringing together lots of different types of expertise to solve those problems. So for this particular project, we have kind of as our faculty members, Carol Adair, who's a climate scientist, Linda Berlin, who's the director of the Center for Sustainable Agriculture, David Connor, who's an economist, Heather Darby, who some of you might know from Extension, Stephanie Hurley, who specializes in water management systems and landscape visualization, and Chris Kaliba and Asim Zia, who both look at climate change issues in the context of policy and governance. So we have all these people trying to kind of put their brains together to both define the research question and the answer to that research question. We don't believe that we can solve this problem on our own, just sitting in the ivory towers. So we have an advisory committee, of which Leslie Ann is one member. We're really lucky to have her. We also try to kind of use this committee to share what we're working on to make sure that it's grounded. So we have extension folks, some farmers, someone from UNH, and Jake Claro, who's part of the Farm to Plate effort, which you probably know about. And then also, just trying to keep the project at large integrated with what else is going on in terms of working on climate change in the state. So the big things that we're trying to do, as I understand it, we're trying to look at what farmers are already doing. What are their best management practices, which is a term that's kind of tossed around as something that's, a practice that's been vetted, that's been proven to be useful, that's been proven not to do too much harm. Which of these practices have the potential to be climate change best management practices? What do farmers do that can limit the amount of risk that they face because of climate change? And how can we provide more information about how climate change is going to be affecting farmers and what they can do to help themselves? Very simplified, this is kind of like a timeline of the project. I'll break it down. We're going to get our context and figure out what's already been done. We're going to do our research. We're going to share our results. I can speak best to two small parts of the work. The first is a review of the Vermont Veg and Berry Growers Association, their reports from the field. Do any of you know, are any of you familiar with reports from the field? No? Every year, or every couple of weeks in the summer and every month in the winter, Vern Grubinger sends out a call to Vermont farmers and asks them just to write a quick paragraph about what's going on in their farm. He's been doing it since 1998. They have a great kind of cataloging of all this information. I went through with a couple of my research assistants and coded for every time somebody mentioned climate change, anytime anyone mentioned an extreme weather event, and specific pests and plant diseases, to try and get a gauge on how farmers are thinking about climate change or aren't. Or are they talking about extreme weather or aren't they? And what we found is that climate change really has only started to come up in what people are kind of casually reporting in the very recent history of the listserv. However, people have been talking about extreme weather for a long time, and that makes sense. We as individuals experience weather. It's really hard for us to experience climate. As Leslie Ann was saying, climate is something that we see trends over decades or even longer. But what we can tell is that it's raining really hard right now, or there wasn't much snowpack this year. And I think that's a really important distinction. I have a friend who says, climate is what tells you what to keep in your closet, and weather is what tells you when to wear it. So the other piece of the work that I'm doing is I'm part of this on-farm research team that is looking at these specific best management practices that I mentioned. My training is in qualitative research, meaning I go out and interview people about why they do what they do, what their motivating factors are, what the constraints on them are. And we decided, based on the expertise of the rest of the team, that we would try and look at specific best management practices. We'd look at cover crops, we'd look at tillage techniques, we'd look at water management, and we'd look at grazing. And everybody is still doing this work. It's like a year-long on-farm research project. The farms that we're looking at, there are 12 of them. We tried to stratify them by vegetable, dairy, meat, or diversified producers, but as many of you know who know farmers or who grew up on farms, in Vermont people do a lot of everything. So it's really hard to bin people. But nevertheless, it's been really interesting to have those conversations. And as I mentioned, these are kind of the components of the on-farm sampling. I'm doing the interviews. The economist on our team is doing a financial analysis of specific practices, so we can say, well, yes, you might want to put in conservation buffers because it's a great, stormwater management tool, but how does that affect your sales or your ability to produce a certain amount of crop X? So really recognizing that there's a financial implication for everything that you do on a farm. And then measuring CO2 sequestration and greenhouse gas emissions, landscape visualization, which I'm going to explain in just a second, and water quality assessments. We're working with Stone Environmental to do some edge of field monitoring of water runoff that will be really interesting, I think. So for the whole time that we were getting ready to do this project, I kept hearing landscape visualization I can't even say it, landscape visualization, and I didn't really understand what that meant, so I wanted to put it up here for you, because once I finally got some visuals for the visual component of this project, it was a little bit of an aha moment. So Stephanie Hurley, who's the faculty member who is working on this, basically uses Photoshop. And she takes a picture of an existing condition, which in this case is a flooded out field down at the Intervale. And she overlays it. And she said, well, this is what I would think it would look like if you added some hoop houses. If you put some more, scrub over here, let this grow up for pollinator habitat. If you diversified what you planted in this field a little bit more. So it hopefully will be useful to inform farmer decision making if they're considering adopting a practice but aren't really quite sure how they want to do it or if they want to do it. It gives kind of some information to those of us who are visual learners. And there is research that this has been useful in other contexts for other kind of land management decisions, but it is the first time that it's been applied to agricultural systems. So it's kind of interesting. And then the greenhouse gas measurements, I have no idea how those things work. But basically, my understanding is that Carol and her graduate student are syncing these into different fields based on different management strategies. So, for example, at Shelburne Farms, they're putting one in an area where they've done rotational grazing and one in an area where they haven't, and they're trying to track what the difference is in emissions. Because we have all this anecdotal information that grazing sequesters carbon and this sequesters carbon, but this is a really good way to test, in Vermont, in this context, is that true? And as I mentioned, a really big emphasis of our work is on extension and outreach, so once we have stuff to share, we hope to share it, both with general public and with farmers and with technical service providers, such as yourselves. So I thought I would just end by opening it up. We have 7 minutes for kind of discussion, which might feel short, but maybe that can just be the official part of the discussion. I wanted to hear from you all what about today in general, not just my presentation, was interesting or exciting or...
Your, for this Drosophila, what are the pesticides we can use, and if they are systemic, is there any washing or soaking or vinegar that gets that out? And do you eat the larva?
So the question is, for the pesticides, what are they? And does washing help? And do you eat larvae? I'll answer them in reverse order.
Okay. Yes.
You eat larvae all the time.
Okay.
They are an excellent source of protein. There is no health risk. I think we all eat more bugs than we think, and I don't think it's a bad thing. I think the bigger concern is, will somebody return a pint of raspberries? So that leads to the second question, which is, can washing help with pesticide residue? I have to admit, I have a little bit of organic blinders on. This is something that I'm working on for kind of my professional development, but because I'm an organic grower and because I've kind of grown up in this sustainability farming box, I don't have as wide a breadth of knowledge about pesticides and how to manage them safely. So I don't know about the washing times or the washing and safety. I think my understanding is that most pesticides do wash off, but have you ever tried washing raspberries?
Yeah.
I mean, I think some fruits can be washed and some fruits can't, and its effect on shelf life is always questionable. I know commercial growers don't generally wash raspberries. It's one of the big things with food safety, right, that's coming out about triple washing and quadruple washing and whatever. Raspberries just don't hold up on the shelf. So even if they're not coming out of your garden, I would always recommend washing raspberries right before you eat them. The pesticides, I have it in my notes, but I don't know them off the top of my head. I do know there are 3 classes of conventional pesticides that are approved. For organic growers, there's one class, but there's nothing to rotate it with, so it's not recommended. I can get you that information if you like. Yeah. Yeah.
You were talking in the beginning when you were talking about your own farm, you said that water management was something that was really key and that what you were focusing on.
Absolutely.
And I think where I am, whether it's too much water or too little water, that's also a concern that I have. What are the different strategies that you use as a farmer in where you are? Because Moncton, are you up on the ridge or are you?
We're off the ridge,
You're off
but
the
we're
ridge.
over by Ravens Ridge, and we're
Ravens.
kind of.
Okay. Okay, so what are you doing with your water management now?
That's it. So Ellen's question was, what are we doing with the water management on our farm? So that's partly why I put out there, we do have a well. It's 40 gallons a minute. I feel pretty lucky, but I haven't been there through a drought, so I don't actually know how that water supply will hold up. I'm kind of crossing my fingers. Long-term plan is to put in a farm pond, but we all know that's an expensive venture. My irrigation system right now is barely effective, and part of that is just my learning curve. We have a frost-free hydrant that fits a regular hose fitting, and I have a 3/4 inch pipe that runs up my hill and back down, and I run my drip tape off of leaders from that main pipe, but it's too small a diameter to really get the kind of water pressure that I need, so I can only run maybe 5 rows of drip tape at a time. And we have, give or take at different points of the season, between 70 and 92 beds. So it makes for a lot of running around. There's a lot of leaky connections. Drip tape is always kind of marginally effective after the first year. But it's better for food safety and it's better for plant health than a lot of overhead irrigation. So we toss up. I definitely think my long-term plan is to get some sort of attachment to our actual well that will allow me to put an aluminum pipe on to run to the top of the hill and then rely on gravity for the rest of it. But it's challenged, but I'm glad I have it. I'll put it that way. Yeah.
We've had some bad drought years, and then everything, ponds, the brook, all our water supply, everything dries up. So we put a big pipe that's this big around from out in the woods up, I think it's about 1/4 mile far up into the woods, in a big brook that never goes dry, and just sort of slowly come down the hill, and I put it in the brook that's dry, and then it just keeps everything the whole summer.
I think it's a really good tactic for. Oh, so sorry, you were relating about you kind of drawing water from a stream or a brook that kind of was consistently running to one that was less reliably running to ensure that you had access to water. One of the things that I struggle with as a commercial grower is that we have a lot of food safety regulations that are coming down the pike. And surface water for irrigation is a really big no-no in there. So as I think kind of long-term about what we're going to do to have a really reliable source of water, I'm really thinking about underground sources as my main source if I can. The pond is kind of an emergency backup, but I need to learn more, and I'm not sure they're even written yet what the regulations will be about length of time in between watering and harvest, or it's tricky, it's complicated, and it's going to affect all commercial growers, but it really does hinge on this food safety issue. I think where food safety comes together with issues about on-farm water use and climate change is going to be fascinating, and I don't think it's necessarily going to be easy. Yeah.
Hi, I grow a lot of fruit bushes. That you mentioned, including the currants and all of that. I live at 1,500 feet in South Starksboro, and I'm very fortunate that I do not have the spotted fruit fly yet, but I'm expecting it this year pretty much. So since I also sell some of these bushes, I get an enormous amount of questions about the fruit fly. do I understand from you, if people tend to buy or would be tending to buy the earlier ripening fruits, that they have a better chance?
Yes, so, and that's actually one of the things that's really hopeful for the blueberry growers in the room is if you can select varieties that ripen earlier, you have a better chance of experiencing lower levels of infestation. When we did our trapping out last summer, just to kind of see how the population ebbed and flowed, we didn't see a spike in population until August, and then it was devastating. But in general, earlier fruits are better. So thank you very much for your attention.